In the last video from step 28, we were practicing solving for a side of the triangle. However, the side we were solving for was usually the easy side. And in this next example, you'll see what I mean about it being a little more challenging to solve for from time to time. In this triangle, if we start off across the 90-degree angle, we know that the hypotenuse is the side labeled x. We know that with respect to the angle we know, which is 24, the side marked 11 is the opposite, and we know that this is the adjacent. We are trying to find x, the hypotenuse. We know O, so we get rid of A because we know nothing about it and we're not interested in it. Connecting O and H is sine. So we'll say that the sine of the angle is the opposite over the adjacent. And this is what I was talking about. This is where it gets a little tricky to solve for x. Before, x was in the numerator, and we just multiplied by the denominator, and we were done. With this, we actually need to multiply both sides by x first. That's going to eliminate x from the denominator. So now we have x times the sine of 24 equals 11. Sine of 24 is just a number, so next we're going to divide by the sine of 24 on both sides. And again, that's going to eliminate by canceling out on the left. And we're left with what x equals. 11 divided by the sine of 24. 11 divided by the sine of 24. Which equals 27.04. All right. We've solved equations for quite some time now that look like this. 3x equals negative 27. To solve that, we just use the inverse of multiplication, which is division. We can do the same thing to find angles of triangles. So far, we've just found the sides of sides of the triangles. Now we're going to find the missing angle. Let's practice with example 5a. Again, we're going to start these problems just like we've been starting them. 17 is the hypotenuse. This is the angle we're concerned with, because we don't know anything about the other angles, so that makes this side opposite. And this side down here is the adjacent. We know that the hypotenuse is 17. We know that the adjacent is 15. We don't care about the opposite. So next we're ready to write our ratio. What connects A and H? Cosine. So the cosine of x, usually we're putting a number there, but now we don't know the number, equals the adjacent over the hypotenuse. And now we're trying to solve. So again, let's think how we would solve that basic linear equation. We would multiply by the inverse, like 1/3, or divide by 3. That would get rid of the 3. Now we're trying to get rid of the word cosine. We can't just divide by the letter COS. That doesn't work. That doesn't even mean anything in math. But what we can do, we can take this 15/17, we're going to just slide it over a little bit, leave some space, and we're going to actually take the inverse of both sides. On the left side, the cosines will cancel out, leaving us with just x. And on the right side, when we type the inverse cosine of 15/17 into our calculator, again, the inverse is right here above the cosine button. So we press the blue button, cosine. Do you see how I put a little -1 there to denote that it's an inverse? And we want 15/17, so 1/5 divided by 1/7. Again, if you'd prefer, you could use a fraction. I'll show you that next. You could also do second cosine, green y equals makes a fraction, 15 over 17, whichever's easier for you. You get the same answer, 28.07. That would be in degrees. All right, let's talk a little bit about angles of elevation and angles of depression. When you're starting out at the top and the angle opens down, that's considered an angle of depression. When you're on the ground and the angle opens upward, that's an angle of elevation. They use those words often in some of the word problems that you're going to be tackling. So let's try the first one here. A golfer is standing at the tee, looking up toward the green on the hill, so he's looking uphill. If the tee is 36 feet lower than the green, this is where his tee is, 36 feet lower than the green, and the angle of elevation from the tee to the hole. So we're starting on the ground and we're opening up to make that angle of elevation right here, 12 degrees. Find the distance from the tee to the hole. So we're trying to find this distance. We need to use the fact that we are trying to find the hypotenuse, but we know the opposite. Again, just like every other problem, let's label things. There's our hypotenuse. This is opposite this angle we care about. And our adjacent. We know the side opposite is 36. We want to find the hypotenuse and we don't care about the adjacent. Connecting O and H, we use sine. Sine of 12 is 36 over H. Again, this is a trickier problem. We have to first multiply by x on both sides, and then finally divide both sides by the sine of 12. So x is approximately 36 divided by the sine of 12, which is 173.15. And that would be in feet. Since these are real world problems, it's important to give some units. All right, let's try the last one here about the roller coaster. This will be our last one for the video. We have an angle of descent or an angle of depression of 60 degrees. So if you're on the roller coaster, you have to start horizontal. And we're not going down. We're starting horizontal at the top here and getting an angle of depression right here. That's how we draw the triangle in. That can be real challenging sometimes, but eventually after you practice it a little bit, it gets a little bit more natural and a little less awkward. We also can label parts of our triangle here. This is our hypotenuse. This is the side opposite. I'm not even going to bother labeling the adjacent side because I would just cross it out anyway. I'm trying to find the hypotenuse. I know the opposite. I'm using my sine function. Sine of 60 degrees is opposite over hypotenuse. We're trying to find the length of this hill from here to here. Again, multiplying by x on both sides. Hopefully things are starting to seem familiar here. We have x sine 60. Show all my work this time. Divided by sine of 60. So x is approximately 195 divided by the sine of 60. 195 divided by sine of 60, which gives us 225.166. We'll round to 17 feet. So another way to estimate that would be to just say 225 feet. Gets a little bit more challenging when we don't have the diagram. So I encourage you to make nice, neat diagrams all the time. We have a ladder placed against a house. So it's important to first draw your house. You can use shapes to do this or just kind of sketch it. But try to make it as neat as you can, because if you have a nice, neat drawing, it usually works better. My ruler is acting a little glitchy here. Here we go. It doesn't have to be an art competition, but you just want to get it close so that you know what you're talking about here. Okay, you can get as decorative or basic as you want. I'll just draw a little front door and a roof on my house. Right here, this is my ladder leaning up against the side of the building. It's a 14-foot long ladder. I know that my 90-degree angle is here where the house meets the ground, and I know that it's 14 feet, so I would label it 14 feet, and it has an angle of elevation of 72 degrees. So that means that this angle, starting flat, opening up right here, that angle is 72 degrees. How high above the ground is the top of the ladder? We're trying to find this distance, this length right here. That's my opposite. I know my hypotenuse, so I'm using sine again. Again, if you want to use the letter O, you can. Just be careful that you don't confuse it with a 0. That's why I used x, since that's the distance we're trying to find. Multiplying by 14 on both sides. We know that x is approximately 14 sine 42. 14 sine 72, rather. 14 sine 72. 13.3.